Hello friends, now we will start with the next topic of power amplifiers, that is the classification of power amplifiers. In this topic we are going to cover almost all types of power amplifiers, and remember, almost 90% questions from power amplifier are appearing from this particular topic, so you should try to revise these points as many times as possible so that you are able to mug up all the points and you are able to handle all the questions from this chapter. So I will start with the class A amplifier first. There are bullet points from this amplifier. Remember, the class A amplifier is a linear amplifier. Its operating point, the operating point of class A amplifier is located at mid of the load line, and BJT remains on for complete cycle of the input signal, right? So let us see the meaning of this. Let us see the meaning. These are the characteristics of an amplifier. Remember, I have discussed that in previous topic as well, that is in introduction to the power amplifiers. This line is called load line of the amplifier, and these lines are the characteristic of the BJT. These are the characteristic of BJT, these lines, right? So the intersection of the operating point, the intersection of the load line, that is this line, with the characteristic of BJT is called operating point, right? So here, remember, if you have small variation in base current, so IB1 to IB3, in that case, if you take this value is IBQ, so your base current is varying about the IBQ like this. That is a small variation. So base current is small, maybe in microamperes, and it is varying about this IBQ value. So if you take the orientation in this way, so this is your base current. Now the corresponding variation in voltage VCE can be taken like this. The corresponding variation when base current is increasing, the voltage VC is decreasing, and when base current is decreasing, your voltage VC is increasing. So there is 180-degree phase difference between voltage VCE and base current. Similarly, if you see the variation in your collector current, when base current is increasing, Q point, your current is increasing this way, so your collector current is increasing, and this is how the variation there is. This is how the collector current is varying. That is the variation in the collector current. This is the corresponding point. This is the corresponding point of the collector current. So we will see the variation. This is the corresponding point for collector current. How I'm taking? I'm taking corresponding point, that is the point corresponding to this, because base current is varying from here to here. So corresponding variation in collector current to this is upper limit of the collector current, and corresponding variation in collector current is the lowest limit of the collector current, and that is how the collector current is varying, right? So your collector current, when your input current is sinusoidal, the collector current is also sinusoidal. Remember, this seems to be small in amplitude, but base current is in microamperes, and normally the collector current is in milliamperes. So the output current is sinusoidal for sinusoidal input current. Therefore, class A amplifier is a linear amplifier. The operating point is located at the mid of the load line. The collector current is amplified version. The collector current is amplified version of the base current for full cycle of the input current. That is, for full cycle of the input current, the collector current is amplified version of the input. So if you see the variation in collector current. So this is ICQ and collector current is varying about ICQ. So the collector current is varying about ICQ. So that is how we have the variation in current in case of the class A amplifier. Now let us see the points further. Class A amplifier essentially operates in linear region of the characteristics. Remember, this region from here to here is linear region of the characteristics. This region, lower one, this region is cutoff region, and this region is called, that is ohmic region, right? So that is not ohmic, rather we will say that is saturation region. So the amplifier operates in linear region, that is Q point is located in linear region in case of class A amplifier. So that is the point you need to remember, right? Now let us see the point. The amplification occurs for the complete cycle of sinusoidal input. So this is the sinusoidal input based current, and this current is also amplified version of for the full cycle. So amplification occurs for the complete cycle of sinusoidal input in class A amplifier. Thus class A amplifier is a linear amplifier which introduces minimum distortion in the output signal. What is the meaning of minimum distortion? The output signal is sinusoidal for sinusoidal input current. What I mean to say is, remember, this current, output current, is sinusoidal for sinusoidal input current. So there is no distortion in the output. Fine. So now, then the power dissipation is maximum when device is off. What is the meaning? Meaning here is the device will be taking maximum current when it is off. The voltage VCE, the product of voltage VCE and IC is the power dissipation, and it is maximum when your BJT is off in case of class A amplifier. That we will see one by one when we go ahead with the detailed discussion on the class A amplifier. But this is the point you need to remember. Then the distortion in class A amplifier is minimum among all the amplifiers. I have already discussed. The output current is sinusoidal for sinusoidal input in case of class A amplifier. Therefore, there is no distortion in the output, or we can say the distortion in output is minimum in case of class A amplifier. And remember, the efficiency is also minimum. Why? Because when device is off, we have zero output, the power dissipation is maximum. So because of that, we have the minimum efficiency in case of class A amplifier. So efficiency should be larger. So this becomes the disadvantage of class A amplifier. The class A amplifier has efficiency, maximum efficiency of 25% in case of direct coupled. We will see that one by one. The efficiency is 25% in case of direct coupled amplifier, and it is 50% in case of transformer coupled amplifier. How efficiency is increased in case of transformer amplifier, coupled amplifier? We will in transformer coupled amplifier, we will see that when we discuss in detail. So these are few points. So the maximum efficiency of class amplifier is 25% in case of direct coupled load, and it is 50% in case of transformer coupled load. So efficiency is almost doubled when we have load connected through a transformer, that is called transformer coupling, and when you have load connected directly in the collector, that is called direct coupled. Fine. So these are few points, and remember, class A amplifier is mostly used as audio amplifier or in audio amplifier, right? So these are the few points related to class A amplifier. What are the points? The operating point is located mid of load line. 2, it introduces minimum distortion. 3, the output signal is sinusoidal version of the input signal, right? Then efficiency is minimum, and there is one more point: power losses occur. The power losses are maximum device is off. The maximum efficiency is 25% in case of direct coupled load, and it is 50% in case of transformer coupled load. These are few points, few objective type points for different competitive exams. You can have lot of questions from this topic, so try to remember all these points. Then class B amplifier. In class B amplifier, remember, In class B amplifier, the operating point is located in the lower half of the load line near the cutoff region. So when your operating point is located near the cutoff region in lower half of the load line, your output signal is amplified version only for half of the cycle of the input signal. Even though input signal may be sinusoidal, but output signal is amplified version of input signal only for half cycle. So output is available only for half cycle. And for remaining half cycle, your device is off, so there is no output. So in case of class B amplifier, your output is not pure sinusoidal. At the output of BJT for half cycle it is sinusoidal, for remaining half cycle it is not there. So one BJT will not be sufficient in case of class B amplifier. So what do? We take two BJTs in complementary arrangement, so that for one half cycle, one BJT is on and that is amplifying, and for negative half cycle another BJT is on, previous will be off, and for a second half another will be amplified. The output coming from both BJTs will be added together to get complete sinusoidal output. So remember, your class B amplifier will be requiring two BJTs, and that arrangement where we have one NP and another PNP is called complementary arrangement. So class B amplifier will be essentially requiring two BJTs, either in push-pull mode or in complementary mode. We will see that one by one. So remember, when the output from one signal is coming from one BJT is coming only for half cycle, so distortion in this amplifier will be maximum. But remember another point, the losses in class B amplifier are minimum when device is off. And if losses are minimum, device is off, the maximum efficiency of the amplifier increases and then becomes 78.5% maximum in case of class B amplifier. So let us see the points one by one. Class B amplifier, in class B operation, the Q point is located at extreme of load line near the cutoff region. That is what I have already explained. So this is your characteristic. So here the operating point is located here. That is where? That is near the cutoff region. This is the cutoff region. So your operating point is located near the cutoff region. So if you see the variation in base current, even though you can see like this, even though your base current will be sinusoidal, because there is no limitation on the base current. Base current is input current and you can give any type of current at the input, so that is sinusoidal. But output will be available only for this much period, maybe depending upon the maximum limits you are taking. Suppose you are taking maximum limit of base current like this. If you are taking maximum limit of base current like this, your collector current will be going up to this. But if you are taking maximum limit of up to this, in that case collector current will be like this. So it depends upon the amplitude of the input current. Accordingly, the amplitude of the output current will vary. That is what I mean to say. So now, for sinusoidal input, your output current is available only for half cycle, right? So your output is amplified version of input only for half cycle. For remaining half cycle it is 0. Why? Because below this your BJT is off, the output is 0. So when operating point is located near the cutoff, device is on, BJT is on only for half cycle. For remaining half cycle it is off. And when it is off, output is 0. So when it is off, output is 0 for negative half cycle of input, and output is available for positive half cycle of the input. That means base current, right? So this becomes important point to be noted. Here the collector current is available only for half cycle, means your collector current is not completely sinusoidal, so your distortion introduced is large, right? So distortion in class B amplifier is large. So your output current is available only for half cycle of the input signal. Your input signal was available for full cycle, but your collector current is available only for half cycle, right? So remember these points. So the Q point is generally selected at collector cutoff voltage, so near this point, right? Then the BJT remains only for half cycle in class B operation. Why? Because for negative half cycle of the input signal, your device is off. Then the output signal is amplified version of the input only for half cycle of the class B amplifier. So in here your output is amplified version only for positive half cycle. For negative half cycle, your device is off, right? Then efficiency in class B operation is more than class A operation because your losses are minimum when device is off, right? And maximum efficiency of class B amplifier is, I have already told, that is 78.5%. That is the maximum efficiency which can be achieved in class B operation. So the distortion in class B operation is more than class A operation. I have already explained. In case of class A operation, your output is completely sinusoidal, but in case of class B operation, it is sinusoidal only for half cycle of the input signal. So these are the points related to class B operation. Then we have class AB amplifier. In class AB amplifier, remember, what is class AB? Class A and B, in between. In between means, in case of class A amplifier, the operating point is located at the mid of the load line. In case of class B amplifier, operating point is located near the cutoff. So when operating point is located between cutoff and mid of the load line, that operation is called class AB operation. That means your operating point lies in the lower half of the load line, but above the cutoff, but below the mid of the load line, right? In that case, your output signal will not be purely sinusoidal. Output signal is purely sinusoidal when operating point is located at mid of the load line. So when operating point is located in lower half above cutoff, your output signal will be distorted during negative half cycle. During positive half cycle, it will be sinusoidal just like class B amplifier. So in this case, your output signal is sinusoidal for more than half cycle but less than full cycle. So that operation where output is available for more than half cycle but less than full cycle is called class AB operation. So in that case, we are getting sinusoidal signal for more than half cycle, so your distortion is lesser than class B operation. Distortion is less than class B operation but more than class A, because in case of class A it is pure sinusoidal. So distortion is between class B and class AB. Efficiency, your losses will be less than class A but more than class B because the device is remaining on for more than half cycle. So losses will be more. So efficiency is between class A and class B. So let us see points related to class AB operation. In class AB operation, the amplifier operates between extremes defined by class A and class B operation. Operating point in class B operation is located in lower half of load line. I have already explained. The BJT in class AB operation remains on for more than half cycle. I have already explained that point. Right, so your device, your output signal is sinusoidal for more than half cycle. You can see carefully, my output is sinusoidal from here to here, which is more than half cycle. Half cycle is up to here, and like this, right? Then the distortion in class AB operation is more than class AB. Distortion in class AB operation is less than class B. Why? Because your output is available for more than half cycle but more than class B operation or class A operation. Why more than class A operation? Because in class A operation your output signal is sinusoidal, we have already seen, but it is not sinusoidal for full cycle. So distortion is more than class A but less than class B operation, right? And efficiency of class AB operation is more than class A but less than class B because your signal is available for more than half cycle. If it is available for more than half cycle, so losses will be more than the class B operation. If losses are more, efficiency will be less than class B operation. But in case of class A operation, your output signal is available continuously, so efficiency is lesser in case of class A operation. Then of course class AB operation. So that finishes your class AB. Try to remember these points. These are very important from examination point of view. You have lot of questions from these points. Almost 90% questions I told, right? So now we have the class C amplifier. What is class C amplifier? Let us see that. The operating point in class C operation is located such that BJT remains only for a period less than half cycle. Less than half cycle. In case of class B, it was on for half cycle. But in case of class C, your BJT is on only for the period less than half cycle. So let us see. And the collector of BJT remains 0. That is, collector of BJT remains 0 for more than collector. There should be collector current. So collector current of BJT remains 0 for more than half cycle, right? So this is how we have. In case of class B, we had like this. In case of class AB, we had like this. Right? That was there. But in case of class C, current is available for a period which is less than half cycle. Right? So remember, if current is flowing for lesser period, losses will be lesser, efficiency will be more. So class C amplifier has efficiency more than class B operation. Right? Fine. So, and of course distortion is more than class B operation. So class C amplifier, remember in class C amplifier we have current which is not flowing even for half of the cycle. So we need to have a tank circuit. What is tank circuit? A parallel circuit having L and C, inductor and capacitor. The parallel combination of inductor and capacitor is called tank circuit. So we need to have a tank circuit which is essentially an oscillator which is able to sustain the oscillations at the output. So in class C amplifier we require LC tank circuit tuned at the same frequency as input signal for maintaining output signal for the complete cycle of the input signal. So remember, when you have tank circuit in amplifier, for producing sinusoidal signal at the output for complete cycle of the input signal, such an amplifier is called tuned amplifier. So class C amplifier is essentially a tuned amplifier. Fine. This amplifier has higher frequency and maximum distortion among class A, B and AB operation, right? So this has highest, rather than saying frequency, please say this is efficiency. This has highest efficiency, right? So this is efficiency here. It has highest efficiency and maximum distortion among all the amplifiers. Fine. The class A amplifier is therefore essentially a tuned amplifier that I have already explained, and it is used in communication systems, right? So these are few points related to class C amplifier. Now let us talk about class D amplifier. This is a small topic. There are questions in engineering services from this topic, maybe in electrical. So class D amplifier is basically not a tuned amplifier. It is basically not a signal amplifier which is used to amplify the sinusoidal signal. Basically it is used to amplify the pulses. The class D amplifier are designed to operate with pulses and digital type of signals. BJT or MOSFET is used as a switch and not linear amplifier in class D operation, right? Using digital techniques, it is possible to have a signal that varies over entire cycle to create output from many samples of the input signal. So basically we give samples at the input, right? And by giving small pulses, small samples, you are able to get output signal that varies over the entire cycle. Such an amplifier where we give pulses at the input and we get output for the entire cycle is class D amplifier. The main advantage of class D amplifier is the device is only for small duration, and its efficiency is ideally considered to be 100%. When device is on for lesser period, efficiency will be more. When device is on for more higher period, more time, efficiency will be less. So that is why efficiency is lowest in class A, then class AB, then class B, then class C, and highest efficiency is there in class D amplifier, right? So remember this point. So ideally it is 100%, but if you talk about practical, it is more than 90% or order of 90%. The audio output from class D amplifier is fed to loudspeaker through simple low pass filter which blocks the higher frequency pulses or high frequency pulses. So these are few points related to class D amplifier. I will not discuss this class D amplifier again in remaining chapter. So try to remember all the points. There can be questions from this topic in engineering services or in PSUs, right? There is least possibility of question in GATE from this topic. So, and that finishes your classification of power amplifiers. Remember, I repeat, this is very important topic from examination point of view. There are a lot of questions from this topic in, especially in engineering services and different PSUs. So in next video I'll be talking about distortion amplifier. So just wait for my next video. Thank you very much for watching the video.